Okay, got that going. Oh, did want to show you one thing. I'll go ahead and start the handy dandy jigger over there. So again, I gotta get an extension cord for my microphone because it's pretty much too short. So, gotta do that. Believe it or not, people, I will get everything organized. Hopefully by whatever next week. Y'all, what day y'all come next week? Yeah. So. We'll try it. There we go. All right, we're good to go now. So, y'all learned so much in Calc 1 that y'all probably can just recite it right off the top of your head, right? Yes, no, maybe? Yeah, I figured y'all could. Like if I was to ask y'all what is the difference quotient, what would you tell me? Yeah. What's the difference quotient? Minus, okay, you're getting there. The rest of y'all are losers. Y'all don't even know what he's talking about. All right. Remember, Calc 1, the first part of Calc 1 is basically the merger of, wrong way. The first part of Calc 1 is the merger of algebra and limits. Okay. When you started learning Calc 1, you started learning about limits. That's the first thing you started to learn about. You already had the algebra in your background. And you put the two together, what did you do with the algebra? Well, you had the difference quotient with algebra. I can't spell quotient, but anyway, y'all get the point. And then the limit, you started talking about getting closer and closer and closer to a point, but never what? Never touching it. Okay? You had to think out of the box a little bit, but never touching it. Get close, 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 but you never touch it. So you took the limit theorem and you took the algebra and you mashed it together, and when you came up with what you came up with was the difference quotient that looked something like limit as h approaches 0 of f of x plus h minus f of x over h. Remember that? All right, this is your algebra. This is your limit. Put them together, and basically you got the difference quotient. Now, what does this mean? Well, I covered this the other day, and I'm going to cover it. I covered it on the video, but I'm going to cover it again just so y'all can get your mind going. Let's say we got a curve here, and we got a spot there and a spot here. In this first spot, we all read left to right, unless you're from the Middle East. That's a lot of people if you are. If you go this way, that's the first. So this spot right here has a value of x, and the value over here of what? F of x, which is a fancy way of writing what? Y. This spot is not x because that's x. You can't say this is x is equal to 3 and x is equal to 4 and 4 is equal to 3. You can't do that. So you have to call this something else. So we're going to say that, and some of y'all may watch the video the other day that I put up, and I did this. I highlighted this portion right here, right there. And some people call that D, some people call it H, some people call it delta, whatever you want to call it. I'm going to call it H. Okay? So what is this point right here? Good job. So what is this y over here. F of x plus h. Okay, everybody with me? All right, now find the slope of those 2 points. What's slope? Slope is equal to delta y over what? Delta x, Hubert. That's right, class. Which is y sub 2 minus y sub 1 over what? All right, plug and chug. So what's y sub 2? Well, here's your y sub 2 right here. Just remember, put your points like this. X plus h, comma, and f of x plus h. There's your 2 points. Okay? X and y. Here's your 2 points down here. X and f of x. Here's your 2 points here. Now, this is x of 1. This is x of 2, y sub 2. This is x of 1, y sub 1. All right, now plug each other. What are you going to get? F of minus f of x over x plus h minus what? And the x's go away, and what do you got? Ain't that neat? So what do you find when you have the difference? Simple as that. Now, the slope with two points like this, far apart, is it rough or is it precise? Rough. So you've got when you got a rough slope like a great distance right here, then that's called the rate of change. So I've got the rate of change with the secant line, and that's what this line right here is called because it's on the inside of the curve. Secant line is on the inside of the curve. When you get the line on the outside of the curve, it becomes the what? Tangent line. But how do you get the line on the outside of the curve? Well, you bring this guy down using your limit theory. And you get it right when it's a half a pin width from this. And that secant line turns into what? Tangent line. And then you not only have a rate of change, when you apply the limit theory to it, limit as h approaches 0 of f of x plus h minus f of x over h. When you do this, when you put this with the slope, you have what's the rate of change called then? Your instantaneous. Make sure I spell it. Instantaneous rate of change, which means I can give you the velocity at any point on the curve. I can give you the distance at any point on the curve. I can give you any magnitude on the curve using that formula. Well, that's all fine and dandy. So let's do a problem. F of x is equal to x squared plus 4. All right, do that one with the rate of change. Now, of course, there's 3 people in the room. One person invented this formula. The other person has no clue what to do. And then the other person says, okay, I remember some of this, but I don't remember all of it. It's been 15 years since I took calculus and all that stuff. So and then there's the other person that's just going to meditate. So just make sure you know which one you are before we start the problem, okay? on my side. So I got a lot of people meditating, and then I got a lot of people that are scribbling, make it look like they know what they're doing. And I get some people that might know what they're doing. I don't know. I make it look good at least, right? If I say f of 2, what does f of 2 mean? I plug 2 in for what? So what does f of x plus h mean? I'm going to substitute x plus h in, correct, right? So here we go. Limit as x, sometimes I put x, I'm sorry, h approaches 0 of f of x plus h. I'm going to write it out for you one more time. Minus f of x over h. So here we go. First thing I'm going to do is I'm going to rewrite this in terms of big parentheses wherever there's an x, so I can plug in my x plus h. So that'd be parentheses squared plus 4. Sorry about that. Y'all supposed to go in the cardiac arrest. Oh, where's my sign? Where's my sign that my teacher puts up? Don't have it up. I got a teacher that goes around here and puts up a sign with a cross through the thought I had it turned down. Let me make sure it wasn't my mama, because she's the only one that don't keep up with my schedule very well. Nope. Alright. Over h. And what do we do when we do f of x plus h? What do we plug in here? X plus h, Hubert. That's right, class. And then what goes here? X f of x. X squared plus 4. All right, now you do your handy math or algebra. Do your handy algebra. So what is this? Shortcut number 1. So that'd be x squared plus 2xh plus h squared. The limit as h approaches infinity 0 of x squared plus 2xh plus h squared minus x squared minus 4 all over h. And the x squareds, what happens to the x squareds? X squareds. They cancel. And you got that 4 is supposed to cancel. There we go. Plus 4 right here. Plus 4. And that final 4 cancels. There we go. And you're going to get limit as h approaches 0 of, I'm going to go ahead and factor out h. H, that'd be 2x plus h over h. And what happens to the h's? They cancel. Plug in 0 for h now, what do you get? And 2x. What is that? Well, I'm going to explain it to you. So, write that down. That's your answer. Now let's take that x squared plus 4. I'm going to go to the next page. F of x is equal to x squared plus 4. Well, first of all, you need to understand what you're dealing with. What kind of function are we at here? A quadratic, which gives us what kind of graph? A parabola. So I'm going to go ahead and find the vertex and everything right quick. X squared plus 0x plus 4 is equal to 0. X squared plus 0x is equal plus blank is equal to 4, negative 4 plus blank. Half of 0 is 0. 0 squared is 0. So we get x squared is equal to negative 4. So we know that can't happen. Why can this not happen? Because you can't take the square root of a negative. So that means no x-intercepts. And our vertex comes out to be x plus 0, quantity squared is equal to negative 4. So our vertex is 0 and what? Negative 4? Be positive 4. That's our vertex. And our let's see, our y-intercept is 0, 4. So our vertex is going to be, so our problem 1, 2, 3, 4. That's our vertex and our y-intercept, so it looks something like this. All right, so there's our function. And yes, you should be able to do all of this. All right. Well, let's pick a point. Let's take a red marker, and let's pick this point right here. Well, it's supposed to be red to work. All right, I want to know what the equation or what the slope of that line is right there. Well, we know that the equation, and that's what we found a while ago, 2x y f prime of x is equal to 2x. And what is that? That is the equation for the what? Slope of the what? Tangent line. That's what you're finding. Now a lot of you saying, God, I can't believe he's going through all this stuff. Listen, I'm going to guarantee you there's somebody in here right now. You don't have to raise your hand. There's somebody right now that has no idea what they were finding in Calc 1 when they found it. I guarantee you somebody in here is going, oh, I know what we're doing now. Because some people don't know how to explain it very well. Okay? I'm not saying I'm the best, but I do know that this is how I learned it because I had to teach it to myself when I was going through Calc 1. And this is how I taught myself. So I want to know what the slope of that line is right there. So if I take my handy dandy doojiggers here, I'm going to say that the slope at that point right there is 1. So I'm going to plug it in. F prime of 1 is equal to 2 times what? 1, which is equal to 2. So the slope of that red line right there is what? 2. We go over here, and let's say this blue line, we call it blue. And we want to know what that slope is right there. And we say that that point is negative 1. So f of negative 1 is equal to 2 times negative 1, which is equal to what? And that's what you're finding when you find the quadratic quotient. But what if you run into something like this? F of x. Oops, sorry. I like to use black because it shows up better on this whiteboard. It's supposed to have this light going on. F of x is equal to, let's go with x squared plus 3x plus or minus 7. And I want you, all of you, to tell me what that is. I want you to sketch what that is, what kind of parabola it is. And I want you to find a point, and I want you to find the slope of the tangent line at that point. So in other words, you're going to have to do everything I just did. So I'll give you a couple of minutes to work on that. I think I can pause this thing. I'm going to try to do it. I wish you can't pause. I thought you could pause the recording. Not gonna mess with it. We'll go ahead and call the roll though. All right. Alexander. Bowling. Corwin. Mr. Fowler is not here. Meadler. Oslin. Robinson. Urban. Vaughn. Williams. Wiseman. That's done. I get some of you started, just to at least do complete the square. That'd be x squared plus 3x plus blank is equal to 7 plus blank. Half of 3 is 3 halves. 3 halves squared is what, 9/4? So x squared plus 3x plus 9/4 is equal to 7 plus 9/4. And then that's going to be x plus 3 halves quantity squared is equal to, dang old 28, yeah, 28 plus 9 is what? 28 is 37, somebody help me out there. 28 plus 9 is 37, 37 fourths. And that gives us a vertex of negative 3 halves and negative 37 fourths. And then x plus 3 halves is equal to positive or negative 6.1 over 2. And then x is equal to positive or negative 6.1 minus 3 over 2, which is going to be equal to 6.1 minus 3 is 3.1. 3 divided by 2 is 1.5, so that'd be 1.55 or something like that. I'm not worried about it. It's close enough for government work. And then negative 9 divided by is 4.55 or something like that. Negative 4.55. We've got a y-intercept of negative 7. So 1, 2, 3, 4, 5, 6, 7. There's our y-intercept. Negative 3 halves would be negative 1.5, and that's what, 4 over 136, what, 9 times? So that's negative 9. So negative 1.5, negative 9 is right here. And then 1.55 is right in here, and negative 4.55 is right in there. So you got some idea of what the parabola looks like, correct? Now, we want to find a point, and I'm going to pick a point. We know that's negative 4.55, so I'm going to go with negative 4. Let's find the slope at negative 4. Let's find the slope of that line at negative 4. So we've got to use our quotient rule. So remember my negative 4 because I'm going to forget it. So let's take our f of our limit as h approaches 0 of, what we got? Quantity squared, x squared, what is it? X squared what?
X squared plus 3x minus 7.
Thank you. 3x minus 7. And that's our f of x plus h minus f of x. And you said it was x squared plus 3x minus 7 all over h. And then x plus h goes here. And x plus h goes here. And notice you're already seeing that you got a lot of what? What are we going to be doing here? A lot of what? A lot of alpha. and I'm doing this for a reason, okay, believe it or not. Limit as h approaches 0 of x squared plus 2xh plus h squared plus 3x plus 3h minus 7 minus x squared minus 3x plus 7 all over h. And what happens to the x squareds? What happens to the 3x's? What happens to the 7's? Everything cancels except for anything with what in it? And that's what's supposed to happen. So limit as h approaches 0. We'll go ahead and factor out of h. That's going to be 2x plus h plus what? 3 over h. And what do we do when we plug in that 0 for h? What happens to this h? Goes out, Hubert. That's right, class. So what is the equation for that line? For the tangent line at any point on that curve? 2x plus what? So what would negative 4 be? Negative 5? Or, let's see. What did I say? Negative 4? Negative 4 times 2 is what? Negative 8 plus what? 3 is negative 5. So what's the slope at negative 4? That's what you should have learned. This right here is what you should have learned. That verse in chapter 3, right when you were going from limits to the derivative. This is what you should have been doing. Because if you use the fundamental theorem of calculus, what was 3x plus 7? Use the fundamental rule of calculus. F prime of x is going to be equal to what? 2x going to be a minus, will be 2x to the 1 power plus, this is 1. 1 times 3 is 3. X minus 1 is to the 0 power plus 0 times 7 is what? 0x to the negative 1. And you come out with 2x plus what? And that's called the derivative. Now you appreciate the derivative because you see what you had to do before you had to do it. You had to do algebra. So you kick algebra out the door, and now you use fundamental rule of calculus. Yes, sir.
Can you just get back to the slide where you found the 0 squared?
Yeah. Oh, that's okay. I just did that right there.
Yeah.
Yeah, I did 0 squared. Oh, you talked about before that.
No, you were right. You were right on the right slide.
That one?
Yes, sir.
Okay. Now, a lot of you are saying, golly, I don't know why you went over that. Well, some of you may be saying, I don't know why you went over all that. Because my job is to teach the person that don't know, that don't remember that. Okay? And to kind of clean it up a little bit where you can remember it. Because I guarantee you, somebody in here is going, oh my gosh, that's so easy. Why didn't my teacher show me the relationship? They did, they just didn't do it in that way. They may have, I don't know. All right, so now, okay, you good? Got a question?
Yeah, well, I was just going to ask where you got the plus or minus 6 plus 1 at.
And square root of that. And square root of 36 is 6, so square root of 37. Now, I don't know what it is on the calculator, but do it on the calculator. It's probably around 6 like that. Now, what do you do when you have f of x is equal to 2x squared y to the third or 2x squared times something else. Let me just, what do you use? It's called a rule. What is it? Or it's called the product rule, huh? Product rule of the derivatives. Okay? Because now you can do a derivative. Let me go back. Let me just do this guy right here. Alright? Fundamental rule of calculus. Now you could plug this into your quotient, difference quotient, and work about 30 minutes or 20 minutes or whatever. Or you could use fundamental rule of calculus, which says 2 times 2 is what? 4x to the 2 minus 1 is 1. Okay, so hopefully y'all know how to do that from Calc 1. So let's go over some of the calculus rules, or some of your rules of derivatives, which is the product rule. And what does the product rule say? And no, I'm not going to write all that crap that they write. I'm going to write it like you should remember it. First times the derivative of the second, plus the second times the derivative of what? That's how you should remember it. First times the derivative of the second, plus the second times the derivative of the second times the derivative of the first. So, let's do an example of product rule. I'm trying to think of one off the top of my head. F of x is equal to, well, you could actually do 2x to the 4th. You could do that one, or 2x to the 6th. All right, do that one. I know it's basic, and I know you could use the fundamental rule of calculus, but I don't want you to do that. I want you to do product rule. You got two terms there. What are they? 2 and x to the 6th. That's right, class. That's called interaction. All right. I ask a question, and y'all what? Y'all answer it. Reply. Yes. Thank you. Coffee, Code Red, Mountain Dew. Okay? Mix them up if you have to. Because I'm not buying y'all biscuits unless y'all start talking. Interact. And when I do buy you biscuits, don't you ask where they're from. You say thank you because they're free. All right, what's the first term? Well, you could rewrite this as 2 times x to the 6th. So the first term is 2. 2 times the derivative of the second, and I usually just put x to the 6th prime. So I write it all out first, and I still do to this day. Plus the second times the derivative of the first. So that's going to be 2 times, that'll be what? 6x to the what? Plus x to the 6th times what? And yes, you could have marked this out just looking at it, and I know that. I know some of y'all are real good at calculus, but that's not who I'm teaching. I'm teaching people to review it, okay? So 2 times 6 is what? 12x. And that's how you use the product rule. Now, you can use it with, I'm trying to think of one off the top of my head, and I can't because you have to put a couple of different variables in there. You could say x to the 6 times w to the 4. You could do that, which I wouldn't do that because then you have to worry about taking the derivative of w with respect to x, and then you have to use implicit differentiation. So let's not do that. But just think of some until I'll look up one here in just a second. But what's after the product rule? The quotient rule. And the quotient rule is denominator times numerator prime minus the what? Numerator times denominator prime over what? Denominator squared. There we go. So denominator times numerator prime minus numerator times denominator prime over denominator squared. Now, if you want to remember it the way they write it, you knock yourself out with it. I'm not writing that. And it's easier for you to actually remember it if you remember it like that. I'm going to have to look up a problem. I can't think of any problems right off the top of my head. So let me just, because you get in trouble if you start thinking and making up problems in calculus. Whew, it gets to be pretty dirty. So let me just look up one right quick. The product rule in, there we go. Let's go with product calc and product rule examples. Okay, one like this, that's good. I want to find something a little bit simpler, but we can. We'll do that one. We'll let Patrick. We'll see. We'll do one Patrick's doing. X to the 4th, 5x minus 1 to the 3rd. No, that's using the chain rule. We can't use that one. Calc 1 product rule worksheet. See, that's why you can't just make up stuff, because then you get in trouble. Okay, math worksheets. I hate when you go to these places. Why don't they just? Let's see, Calc 1, no, calculus. Here we go, calculus. Product rule, okay, yeah, that's what I'm looking at. Product rule, there we go. Yeah. All right, there's one you can do right there. That's using the chain rule. That's not using the product rule because you got to use the chain rule right here. Well, we'll just go over the chain rule and then we'll just knock both of them out. Quotient rules down here. See what they got on the quotient rule. Yeah, now you can use these. That's fine. Let's do. Can't use that one because that's chain rule. X squared over 3x minus 1. X squared over 3x minus 1. X squared over 3x minus 1. So, denominator, 3x minus 1, times numerator prime, which is going to be x squared prime, minus the numerator, which is x squared, times 3x minus 1 prime over 3x minus 1 quantity squared. And I'm just going to take a red marker and make that prime red so y'all will know you're going to take the red. So that's going to give you 3x minus 1. And what's the derivative of x squared? 2x minus brackets x squared times, what's the derivative of 3x minus 1? 3 over 3x minus 1 quantity squared. I'm not going to worry about that denominator until the end. And this is going to be what? 6x squared minus 2x. Minus 3x squared over 3x minus 1 quantity squared. And 6x squared minus 3x squared is what? 3x squared minus 2x over 3x minus 1 quantity squared. And I'm not going to go any further. You might be able to factor out the x, but that's all you're going to be able to do is factor out the x, because you're going to get a trinomial on the bottom. 9x squared minus 6x plus 1, but you're not going to be able to cancel anything. So factor out the x right there, and that's about either this answer or factor out the x. And that's how you do the quotient rule. And the last one, of course, is the chain rule. Now, the chain rule, I just write it out. Take the derivative, then the derivative multiply by derivative of, and I put in quotation mark, what's what? What's inside. Okay? That's the chain rule. Huh? Yeah, they had them on the product, but I thought they had the chain rule on here. They don't have the chain rule on here. They just assume you know it, I guess. Yeah, that's the chain rule right here. So we'll just do one like this. We'll do it a little bit different. We'll change it. Let me just get out of that. Go back to what I was doing. Let's go with f of x is equal to f of x is equal to parentheses 2x squared plus 1 quantity squared. All right, now I want you to take the derivative of that using the fundamental rule of derivative, or the power rule. Then take the derivative of what's inside the parentheses, and you've just done the power rule. I mean the quotient, the chain rule. This is where students, if they didn't get confused with the difference quotient and the limits, this is where students get confused probably the second time in calculus, is at the chain rule, because one, of how it's presented, and two, because you're doing 2 or 3 things at one time. What I tell students to do is do it separately. Do your product, do your power rule first. Power rule first. This 2 comes where? 2 times 1 is 2. And then we got 2x squared plus 1. And then 2 minus 1 is what? 1. So you just did the power rule. And now, what's inside the parentheses? 2x squared plus 1. That's right. 2x squared plus 1. And I'm going to put a red tick mark on that, meaning that I've got to take the what? The derivative of what's inside. No talking about that. So, that gives us 2 times 2x squared plus 1 times, well, what's the derivative of 2x squared? 4x. And then that 4x multiplies by that 2x, or 2, and you get 8x, 2x squared plus 1. And you can distribute that if needed. It doesn't matter. I'm not going to worry about it at that point. I have to take that answer, or I'll take 16x squared plus 8x. Question, gripe, complaint. How are we feeling? We feeling reviewing? We in review mode yet? Enough to do at least what? 5,000 problems? How many did you say? 1,500? Okay. Enough to do 1,500? All right, let's try nerd. Let's go back to the worksheet. I wish they did have some on chain rule. I don't know why they don't have it. I guess you're just supposed to know it. That's a good Calc 1 review sheet. That's a pretty good review sheet right here. Because that's what I'm doing, except they don't have a chain rule on here. Alright, let me see if I can find one. That's a good one. Alright, let's do... Sure, they even got the answers. Let's do this one right here. I'm going to put the cursor on it and I want you to do it. I'll blow it up for you. Why did he have to go off and give us this problem? It's got a radical in it. Radicals and calculus don't what? Mix. So that's the first thing your Calc 1 teacher should have told you. Radicals and calculus don't mix. What are you supposed to do to a radical anytime you see it in calculus class? Change it to a rational exponent. I'm glad y'all all knew that right off the bat. Yeah, I know that.
you don't have to use the chain rule on this one too much, but I just figured I'd throw it in there because of the radical. Golly, y'all sound like y'all sick. Y'all need dang old drink orange juice with Mountain Dew mixed in with it. Huh? Well, you need to throw some of that vitamin C in there because I don't think you're going to get any vitamin C out of Mountain Dew. If it is, it's done been synthesized. All right. What is our problem? F of X equals what? Hold on, I got it. F of X is equal to X cubed over the square root of X plus 1. Okay, so the first thing I'm going to do is change that radical into a rational exponent because you don't want to deal with radicals in calculus. So that's going to be equal to X cubed over X to the 1/2 plus 1. So denominator times numerator prime minus the numerator times the denominator prime over denominator squared and that looks too much like a 1. Yeah. All right, so x squared plus 1. What is the derivative of x cubed? 3x squared. So that's going to give us x to the 1/2 plus 1 times 2x squared. 3x squared. Minus x cubed times the derivative of this guy is 1/2 x to the negative 1/2. All that over this. What? We're gonna do that in a minute. I ain't gonna lock y'all down right now. If I throw too much algebra up here, y'all go into a tailspin. Can't do that. Alright? So 3x squared, you can distribute that out. 3x times this, 3x times that, you can do that. And then right here, be careful because you got this guy, this x to the negative 1/2 needs to be brought where? Downstairs, and you have x cubed over what? 2x to the 1/2, right? So anyway, that's going to be 3, let's see, x be 2 plus 1/2 is what? Let's see, 5/2, x, 3x to the 5/2 plus 3x squared, brackets, minus, and that's going to give us, I said it a while ago, x cubed over 2x to the 1/2. Y'all check me.
You can simplify that to the 1/2 power factor. I said you can simplify it to 1/2 x to the 5.5 power.
Well, we will just a second. Yeah, you can simplify all of this. Yeah, I thought you meant something else. I'm sorry. And this right here is going to be x to the 1/2 plus 1 raised to the 2nd power. And then I'm going to take this, if it'll let me. You know, I have a, let's see, it'll do it, there we go. Good figure. I work with CAD every day in the surveying business that we have. And it might have helped this company if they would have asked CAD for a little bit of input on how to, you know, pick apart, explode something, because they sure didn't do it right on this program. They should have went to CAD and said, give us some pointers. But anyway, I'll show you. I can't do anything here really. Back out of 3, but we're not going to worry about that because we may be able to cancel something. Something may cancel out. I don't know. 3x to the 5 halves plus, well, you can, no, you could, no, you can't. 3x squared minus, and you could rewrite this or use your quotient rule, 1/2, and then go out here and go x to the 3rd minus x to the 3 minus 1/2 over, and then this can go, if you take, that'd be x to the 1/2 quantity squared plus 2x to the 1/2 plus 1, and then that's going to give you 3x to the 5 halves plus 3x squared, and then this comes out to be, what's 3 minus 1/2? Well, 3 minus 1/2 is 2.5. The 2.5 doesn't help us because 2.5, that gives us a decimal. We can't work with decimals. So we need to change it into what? 5.5? 5 halves? Okay. Or what? 5 halves, right? Okay, 5 halves. So that's going to be minus 1/2 x to the 5 halves over x plus 2x to the 1/2 plus 1. These two guys can cancel, or not cancel. But what's 3 minus 1/2? Yeah, so that's going to be equal to 5 halves x to the 5 halves plus 3x squared over x plus 1 plus 2x to the 1/2. And you might have to simplify it some more. That's a yucky problem. Let's see what they got as an answer. I don't know how far they went. I wouldn't go too far because it's just algebra that you're doing. Let's see what they got. What number was it? Is that it? Yeah, they didn't even expand the bottom. They just left the bottom alone. So you could do that and see if they got, did we get the same thing? Right on top. All right, so that's how you do that one. I will see if there's another good, no, there's not. All right, so that's how you use the chain rule. Don't forget your logarithmic rule. Dang old natural log, dang old 1 over x. Don't forget that. Let's go, I'd like to go, y is equal to the natural log of x. I'll just write it down. Y is equal to the natural log of x. Or f of x is equal to the natural log of x. However you want to write it. Y is equal to the natural log of x. Y prime is equal to 1 over x. Now, the rule there is going to be explained to you with a later rule that you take the derivative of the denominator over the denominator. That's what you actually do. But you'll see that later because, you know, what's the derivative of x? du over u. You take the derivative, it's du over u.
So you can do it now or do it later. du is 1, u is x, so you get 1 over x. You see it later when you do the u substitution and all that stuff, but that's just a basic. And if there was a 5 out here, well, you could do it 2 different ways. That 5 would go out here, right? And then you have the natural log of x to the 5th. Well, x to the 5th would go on the bottom, but what's the derivative of x to the 5th? 5x to the 4th, so you'd have 5x to the 4th over x to the 5th. You can do it that way. You know, however you want to do it. The main thing that you know, that you remember here is just remember this, because you're going to see it, and you just need to remember it. Okay? That's that one. The trig functions, I'm not going to go into the trig functions that much because that's something you should have memorized. The derivative of the sine is the cosine. The derivative of the cosine is the negative sine. So on. So you should know those. If you need to revisit that, look in your book, and somebody tell me where the derivatives are and what chapter in the book. Somebody look right quick. Chapter 3. I thought it was either chapter 3 or chapter 4. So just find it right quick for me.
Start the differentiation on chapter 3.
Okay. So go back to chapter 3 and look for the page that's got all the derivative laws on it. So you can, that's what we're doing right now. Implicit differentiation. So let's take a look at this guy. X squared plus y squared is equal to 25. And just let you remember what implicit differentiation is. X squared plus y squared is equal to 25. Write that down. X squared plus y squared is equal to 25. Now, implicit differentiation is not hard. What I tell students to do is always think in terms of y. Y. Don't think in terms of all this dy, dx, and all this other stuff. All right? Think in terms of, y is what you want to solve for. But the problem is, you've got to take the derivative of everything. But you can't take the derivative of y and say, okay, the derivative of x is 2x and derivative of y is 2y, so you get 2x plus 2y is equal to 0. Well, there's a rule in calculus. Nothing is that simple. If you think something is that simple, chances are what? You're not correct. Alright? You remember some of the limits that you did back in Calc 1 and you had x squared plus, or you had something over something and you said, well, heck, all you got to do is put in 0, zero's it. No, that's not right. It's not going to be that simple. This one is not that simple. You can take the derivative of x. What's the derivative of x squared? 2x. But this guy, you can't do that easy. You have to rewrite it as 2y and then put multiplied by what? Y prime. Good. Some of y'all have a good teacher that uses y prime. You start using dy, dx, and all that other stuff, you're going to get what? Confused. So put y prime. Good job. So that'd be 2y times y prime is equal to what? 0. And now what are we going to solve for? Y prime. Good. Y'all have some good teachers, sound like. Some of y'all ain't saying anything. And if you're not saying anything, we'll just leave it at that, okay? If you're not answering, that means you're either quiet or you didn't have a good teacher. Alright, so I'm going to solve for y prime. Bring this over, so that'll be 2y. Y prime is equal to negative 2x divided by 2y divided by 2y. Y prime is equal
to negative x over 1. That's how you do implicit differentiation. Where is the most important part of implicit differentiation? Right there. That's the most important part. If you write the y in terms of y prime, then everything will be okay and you just go back to algebra. Let's do a nerd, just so you'll have a couple of y prime, some implicit, because I'm going to give you a couple on your first test, just to make sure you reviewed. So let's go back to our, there we go, let's do that one right there. I'll just put the cursor on it. X squared y cubed plus x cubed y squared is equal to 1. Oh my gosh. We gotta use product rule twice. Yep, I'd quit. Just throw your pencil down in disgust and just don't do it. Takes too long. Just erase some of it. That's what you ought to do. Just erase it. Change the problem. People are sickly. The easy way. I'm not going to rewrite it. I'm just going to make it transparent. There we go. So, first of all, you need to rewrite it. And rewrite it in a way that's organized for you. In other words, I'm going to say first times the derivative of the second, plus the second times the derivative of the first. We'll put that in brackets. Plus the first times the derivative of the second, plus the second times the derivative of the first is equal to what? I'll do that one for you. 0. I'll do that derivative. Y'all do the rest. I used to have an instructor in Clemson and Dr. Ruffle. And every time he would have an easy problem, it was easy part of the problem, he said, I'll do this for you. I just do it. He was like 107, been teaching at Clemson for about 50 years. He had done so much calculus in his lifetime that you could make up any problem. I don't care how hard you made it up. And you would put it on the board and he could do it in about 5 or 6 seconds. I mean, it was just amazing how much he could do, how much he knew. But if you go to his office every day, you go to office hours and knock on the door, scared to death because he had his back to the door and he played Tetris all the time. Remember Tetris? And he just played it. He played it all the time. And you would knock on the door and you jump about that far out of his seat because he was so into the game. And like I say, he's about 107. But anyway, I'll do that one for you. All right. So here we go. X squared times 3y, y prime. Oops. All right. Plus y cubed plus 2x, or times 2x, and I'm going to put that in brackets, plus x to the third, 2y, y prime, plus y squared, 3x squared is equal to 0. Now, about the only thing you can do is go ahead and get rid of all the brackets and stuff, because what you're going to have to do is get the y primes what? Together. Yes, together and by themselves. Then before you can factor out the y prime and then you can solve it. So I'm just going to rewrite everything. I'm going to distribute that positive 1 and that positive 1 and get rid of my brackets. And I get x squared times 3y squared y prime plus y cubed times 2x, and you could do that 2xy cubed if you want to, plus x cubed 2y y prime plus y squared times 3x squared equals 0. Now I would probably take these two and combine them as much as possible and move them. I'll do that now. So what is that? 6xy cubed. 6xy cubed. And this is what? 3x squared y squared, right? So that'd be a minus and a minus. 3x squared y squared. And then over here, let's take them out. That's gone. And that's gone. And we can factor out the y prime, right? And yes, I'm skipping a couple of steps, but you should be able to do that. X squared, 3y squared, plus x cubed, 2y. So y prime is equal to negative 6xy cubed minus 3x squared y squared
over x squared 3y squared plus x cubed 2y. Somebody check me. Is that what y'all got?
Can I just ask where you got the 6 on my next part?
I probably just made it up.
I think you multiplied the 3 and the exponent to.
Oh yeah, I just multiplied to, yeah, I just make up stuff. Sometimes I make mistakes. Guess what? Y'all do too. But you did that in a very good way. You said, where did you get the 6x? I can't stand it when I have a class and one person says something and 5 people behind them say, oh yeah, you got it wrong. And Bubba's sitting on the back, yeah man, you got it wrong. And then I asked Bubba, what's wrong? What's wrong? Where do I get it wrong? Mm-hmm. You did a good job here. Good job. All right, take that one out. Sorry about that. I did that because I wanted to make sure y'all were on the way. Yeah, that's what I did. I did that on purpose. All right, is that what you got?
I think the 2 goes in where the 6 was.
Dadgummit. Did I miss up something else?
The 2 goes where the 6 was.
Oh, I just took out the whole number, didn't I? There we go. 2 and 2. How about that? Is that better? I suck. All right, let's look and see if that's what they got. I don't even know which problem it was, but there, it looks like that one right there. Is that it? They got some, oh, there it is, 3 and 2, there it is. Looks like we got it right. Let me just flip this over. Y'all check it and see. They might have factored out a negative. Okay, that's not a big deal. I don't care about that. Just make sure all the coefficients look. Make sure there's no 6 in there, okay? Question. But that's a good problem. That's a good test question right there. I mean, that's about as far as the review, that's as far as the implicit differentiation, that's about as difficult as I'm going to get on that. That's a tedious problem. Okay? Okay, we good there on implicit differentiation? Y'all knocking the cobwebs loose? Good. Oh, shoot. Did I just... Oh. Which one was it? I did a worksheet, didn't I? Oh, me. I was the reason I was going to go back to that worksheet is because it's a good review worksheet. I didn't look up review worksheet. I just did calculus, but it sure is a good worksheet. Man, now I can't find it. Which one? This one? But that's not. There we go. Is this it? Yeah, there we go. Thank you. Yeah, it is a good worksheet. There we go. Dang old Calculus 1 for Dummies. Let's see. Power rule, we already talked about that. Well, that's integration. I think we've covered just about hyperbolic. We're not going to do hyperbolic because that's 5.6 and 5.7. We're not going to do that. We'll do that after we review. All right, let's do an exponent. Let's do that one right there. 43 to the square root of x. Find the derivative. That'll be our last one for today. 43 square root of x as the exponent.
Now this one is a function of, I done lost it. There it is. At square root of x, I'd rewrite that as x to the 1/2. So yeah, it is. So actually you've got f of x is equal to 43 to the x to the 1/2 power. Now, when you have a exponential function, the best thing to do is just pull that sucker out, and you're going to have x to the 1/2 times the natural log of 43 x to the 1/2 times 1/2 x. Is that correct? Did I write that? Did I say that right? Got to pull that out, so that's going to be x to the 1/2, because you always pull that out. Then you multiply by the natural log. I'm thinking should be the natural log, right? Natural log of 43x to the 1/2. X to the 1/2. And then you take the derivative of this right here, and that's going to be what? 1/2 x to the negative 1/2? 1/2 x to the negative 1/2? And of course, this is 1/2, or 1 over 2x to the 1/2. And then you can take that one, multiply or combine it with this one. So that's going to be, or you could take this one and multiply it. That's going to be adding the exponents. What do you come out with? X to the 0? Help me out there. So you get x to the 1/2, put a 1 in there, times 1/2 x to the negative 1/2 times the natural log of 43 x to the 1/2. I don't think that's going to be right, because the x to the 1/2 is going to cancel. That'd be x to the 0. Okay. Whew. I thought 0 is going to cancel the whole thing. That's x to the 0, which is what? 1. So that turns out to be 1/2 natural log of 43 x to the 1/2. I think that should be the answer. Let's see what they got. Huh? Go ahead. I mean, I haven't done one of those in a long time, so I could be wrong.
I think the x to the 1/2 exponent is supposed to be, it's supposed to have a negative 1/2.
You're right. It's supposed to. Negative 1/2 right here. Right here? Okay. Probably, yep. Let's see what they got. Natural log of 43 x to the 1/2. Well, we got that much right, but we forgot 43, and there's the 2. We got a couple of things. I got a couple of things wrong. I tell you what, let's stop there, and let's go ahead and I'll do exponents when we start back, whenever that is. When do y'all come back?